Our second example is the exponential function given here by this equation. F of t is equal to e to the minus alpha t multiplied by u of t, which is a step function. The step function is used just only to fit our definition of our Laplace transform definition, which integrates from 0 to infinity. And that's what this u of t is for, because we know that e to the minus alpha t exists from minus infinity to infinity, and multiplying this exponential by a u of t forces this function to be defined from 0 to infinity. So what we want to do is take this time domain description of the exponential function and show that it's transformed into the Laplace domain description of 1 over s plus alpha. So we start off with our definition of the Laplace transform going from 0 to infinity, where we have our integrand as f of t e multiplied by e to the minus st dt. Substituting this function f of t into our definition, we have e to the minus alpha t. Now u of t doesn't need to go in here in the integral because we already defined our limits from 0 to infinity. So here we have e to the minus alpha t multiplied by e to the minus s of t, and we see we have a common base, so we can add the exponents, which leads to an exponential of e to the minus quantity s plus alpha t, integrating from 0 to infinity again. Very similar to what we did with the step function, except for the step function alpha is equal to 0. So what we have now is the integral of that results in e to the minus s plus alpha quantity times t divided by s plus alpha with a minus sign in front. That's the result of integrating this exponential function. And we're integrating from 0 to infinity, so our upper limit is infinity and our lower limit is 0. And doing that makes this upper limit equal to 0. E to the minus infinity is 0. And then e to the 0 is just 1. You have a minus and a minus sign, which makes it a positive sign, which results into 1 over s plus alpha. And that's what we proved. Now again, just to show a relationship between example 1 and example 2, where example 1 is the step function, when alpha is equal to 0, that's just 1 over s, which is just the step function. And when you substitute alpha equals 0 here, we're just left with the step function. So that's a nice tie-in between example 1 and example 2. That's it for the exponential function and what its Laplace transform of the exponential function is.